Alright, the topic of this video is sequences and looking for patterns. Alright, so here we're given some sequences here, arithmetic sequences, and we're asked to get the next three terms. We gotta look for a pattern. We gotta look at what happens from 3.2 to 3.5. Well, that increases by 0.3, and then from 3.5 to 3.8 also increases by 0.3, and then 3.8 to 4.1 increases by 0.3. So if we got to look at 4.1, if we add 0.3 to that, it becomes 4.4. If we add 0.3 to that, that becomes 4.7. If we add 0.3 to that, it becomes 5.0. If we write a rule for this, we start with 3.2 and then add 0.3 repeatedly. Alright, we look at the next one. It goes from 6 to 4, so it goes down by 2. So we're subtracting 2, then 4 to 2, subtracts 2, 2 to 0, subtracts 2, so each time we're subtracting 2. So look at the last term we were given here. We got negative 2, so we subtract 2 from that, we get negative 4. Subtract 2 from that, we get negative 6. Subtract 2 from that, we get negative 8. And the rule here is that we started with 6, and we subtract 2 repeatedly. Alright, so now we're looking at geometric sequences. The first term we got here in this first example is 128, and it goes to 64. We do that, that's dividing by 2, and then 64 to 32 is dividing by 2, or you could say multiplying by half, and then 32 to 16 divides by 2. So we're looking at 16, cut that in half, we get 8. Look at 8, cut that in half, we get 4. Look at 4, cut that in half, we get 2. So a rule here that we could write for this is start with 128 and divide by 2 repeatedly. We could also say multiply by 1/2, or multiply by 1/2 repeatedly. If you look at the next one here, we go from 2 to 6. That multiplies by 3. 6 to 8 multiplies by 3, and 18 to 54 also multiplies by 3. So if we look at 54, multiply that by 3, we get 162. If we take 162 and multiply it by 3, we get 486. And if we take 486 and multiply it by 3, we get 1,458. The rule we could write for this is that we start with 2 and we multiply by 3 repeatedly. Alright, so here we have three sequences. We want to write the first 4 terms for them. Typically when you see a sequence, the notation for it is AN equals that, and then you write in the sequence here. So now, if you want to find the first term, wherever you see an N, you put on a 1. So this A of 1 is like saying the first term. But wherever you see the N, you put in that number. So here we have, in parentheses, 1 plus 1, which is 2. Multiply that by 1, you get 2. So the first term in that sequence is 2. If you wanted to find the second term, wherever you see an N, you're going to plug in the number 2. So in parentheses, 2 plus 1 is 3. 3 times 2 is 6. If We want to find the third term. Again, wherever you see an n, we're plugging in 3. So in parentheses, 3 plus 1 is 4. 4 times 3 is 12. The fourth term, wherever you see an n, plug in a 4. So in parentheses, 4 plus 1 is 5. 5 times 4 is 20. So the first four terms in this sequence are 2, 6, 12, and 20. Dot, dot, dot. For this next one, again, if we do a to the n equals 4 plus 2n, if we want to find the first term, plug a 1 in there. So wherever you see an n, you plug in a 1. So we have 4 plus 2 times 1, which is going to give us 6. If we want to find the second term, 4 plus 2 times 2, which is 4 plus 4, which is 8. Find the third term, wherever you see the n, plug in a 3. So that's 4 plus 2 times 3, and that's going to give us 10. And 8 of the fourth term, wherever you see the n, plug in the 4. So that's like saying 4 plus 2 times 4, which is going to give us a total of 12. And if you list the first four terms here, we have 6, 8, 10, 12, dot, dot, dot. Alright, for this last one, 3 to the n. So we have a to the n is 3 to the n. So we want to find the first term, 3 to the first power. Well, that's 3. We want to find the second term, 3 to the second power. That's 9. Third term, 3 to the third. That's 27. And then a to the fourth would be 3 to the fourth, which is 81. So our first four terms are 3, 9, 27, 81, dot, dot, dot. Alright, so here we want to write a rule for the nth term for this particular sequence. So going from 2 to 5, that increases by 3. From 5 to 8 increases by 3. 8 to 11 increases by 3. So I suggest first starting off finding a to the 0 term. So that means what would be, if you went back from 2, what would that term be prior to what's already here? Well, since it's increasing by 3, if we go back by 3, so if we've got 2, 5, 8, 11, and 14, if we went back and found this term, that would be negative 1. So we know that our starting point is at negative 1, and each time it goes up by 3. So I'm going to change this and call this a to the nth. So negative 1 plus 3n. If I want to find the 120th term, wherever I see an n, I'm going to plug in 120. So that's negative 1 plus 3 times 120, which gives us negative 1 plus 360, which is going to be 359. So the 120th term, if you continue that sequence out, would be 359.